All right, moving on. Now we're on section 2.5. We're going to spend 3 days going over 2.5. So this is the first video. The last section we went over how to find, basically how to use complex numbers, how to use a quadratic formula. If you get a negative and a square root, then that means you get an imaginary number or complex numbers. It means it doesn't hit the x-axis at that point. Now we're going to put it all together. We're going to do the same thing really that we did in the beginning of chapter 2. We're going to find all the zeros, but now we're going to find all different types of zeros, real zeros, rational zeros, and also complex zeros. And I have this as a little intro right here where it has find all the real zeros. Now our degree is 4. All right, so let's find the zeros. As I said, the degree is 4. So this means we're going to get 4 real zeros. Now this one right here, if I set this equal to 0, I can actually factor this. This would be difference of 2 squares. Eventually we're going to use synthetic division to kind of find the real zeros first, and we want to get it down to a quadratic, and then use quadratic formula to see if it gives us real zeros or complex zeros. But this I can factor. I'm just going to give you an easy one to kind of give you the main concept of what we're doing. This is going to factor to x squared minus 1 times the quantity of x squared plus 1. Right, difference of 2 squares. Now we still have another set of difference of 2 squares. That would factor to x minus 1 times the quantity of x plus 1. This would not factor because it's not a difference. It's the sum of 2 squares. So that's still just x squared plus 1. Now if I set these equal to 0, I know that I get 1 and negative 1. These are 2 real zeros. This right here is going to give me imaginary zeros. Right, I would have x squared equals negative 1, take the square root, you would get plus or minus, and the square root of negative 1 is I. So my 4 zeros are 1, negative 1, and then I, and negative I. So this is what we're going to be doing. We're going to be getting all the zeros, and it could be real or it could be complex. Now you can see I have this underlined. I'm going to circle it now. There's no graphing calculators. Now, we're going to do ones where it doesn't factor like this. So instead of factoring, I'm going to use synthetic division, and then, as I said, get it down to a quadratic, and then we'll factor it. Now, before I do this, without a graphing calculator, what kind of eliminates options for me, or it kind of gives me options, let's look at the rational zero test. Probably a lot of you guys have seen this before. All right, now I have the whole definition here written out. If this is our function that we're given, you might say, well, how do I know what numbers to plug in? We're not going to be given any zeros, or we're not going to be given any factors. Now, this is what every possible rational zero for the f of x is this plus or minus p over q. Well, what does that mean, plus or minus p over q? Well, p we have here, this is a factor of the constant term, a sub o. So this is the constant. And q is a factor for the leading coefficient. In this case, it's a sub n. All right. Now, if I applied this to the last one, the p in this case is the 1. Well, the only factor for 1, I'm going to put plus or minus, the only factor for 1 is 1. The q, that's the leading coefficient. The factors for leading coefficient, well, the leading coefficient is also 1. It's this. So your only possible rational zeros are plus or minus 1. And look, it makes sense because when we solve for it, we got these to be the answers. Now you're going to have, sometimes you'll have a long list of possible rational zeros, but you only have like maybe 1 or 2 of them that works. For first one, it actually worked out that it was both of the zeros indeed. All right, let's apply this. Now the whole purpose of the rational zero test is this gives us options to use synthetic division, to find the zeros, and here's the main part. We're not going to be given the zeros, and we're not going to have the graphing calculator. So before I use synthetic division and try to find the zeros, let's just do this. Let's list all the possible rational zeros. And again, we'll talk about what this means. All right, now the plus or minus p over q. Let's look here. So again, if I look up, p is the factors for the constant term. All right, so if I look at 1, this is p. I'm going to put p over q, and it's plus or minus. Now this is the constant term. 4. All my factors for 4 are 1, 2, and 4. Q, that represents all the factors for the leading coefficient. Well, this is the leading coefficient, 6. All my factors for 6 are 1, 2, 3, and 6. Now what I do for this is I take this 1 and I put it over all of these terms. So if I just kind of use an arrow here, whoops. All right. Okay, so basically what I'm doing is I'm going to put 1 over 1, 1 over 2, 1 over 3, and 1 over 6. They're going to be possible rational zeros. So I'm going to write that down. So I'm going to have plus or minus, I'm going to put 1, 1 over 2 is 1/2, 1 over this 3 is 1/3, and then 1 over 6. And then I'm going to use the 2. I'm going to put 2 over everything. So 2 over this 1 is 2. 2 over 2 is 1. That's already on the list. Then I have 2 over that 3, which is 2/3. 2 over 6, that reduces to 1/3. That's already on the list. Okay, then I take the 4. I'm going to do the same thing. I'm going to put the arrow again here so you guys see what I'm doing. So if I do, I'm going to put the 4 over 1, 4 over 2, 4 over 3, 4 over 6. So that's going to be in my list. So 4 over 1 is just 4. 4 over 2, when I do this, well, that's 2. That's already on the list. 4 over 3, that's not on the list. And 4 over 6, well, that reduced to 2/3. That's already on the list. So this is my possible list, and it's plus or minus for all of these. All right, like it's plus or minus 1/3, plus or minus 1/6, plus or minus 1/2. Usually I just put the plus or minus on the outside. But what this is telling me is when I use synthetic division, I'm only going to use these values for synthetic division. That'll only give me the possible rational zeros. Not all of them are going to work. Probably only a couple of them are going to work. And then from that, we can use quadratic formula, or we could try to factor the quadratic. Okay, let's do number 2. Number 2, if I do, let's see here, plus or minus, all my factors for P are all my factors for 12, which are 1, 2, 3, 4, 6, and 12. Now my leading coefficient is 1, so this is actually going to make it a lot easier. The only factors for 1 are 1. So if I take all these numbers up top and I divide them by 1, it gives me those numbers. So my possible rational zeros are plus or minus 1, 2, 3, 4, 6, and 12. All right, so this gives us a starting point of what numbers to choose from when we use synthetic division, because we're not going to be given the zeros. We're not going to have a graphing calculator to see where it hits the x-axis. All right, we're going to do 3 and 4, and then the numbers, the ones on the back, 5 and 6, we'll do in class tomorrow. So let's do this for 3 and 4. All right. Now for 3 and 4, I'm going to use synthetic division. Let's first list the possible rational zeros. So let's put plus or minus. Okay, my factors for this 6 are just 1, 2, 3, and 6. And my only factors for leading coefficient is 1, so it's just 1. So these are all my possible rational zeros. Okay, I'm going to put 1. I always like starting with 1. And I'm just going to, a lot of this is trial and error. I want to get a remainder of 0 when I put these numbers in for synthetic division. So I'm going to put, let's see here, 1x to the 4th, negative 1x cubed, 1x squared, negative 3x, negative 6. Okay, and if I put 1 in, let's see here. I would do this in a pencil because I'm going to do some where we don't get a remainder of 0 and we're just going to do it over again. All right, so then 1 times 1 is 1. I add these, I get 0. 0 times this 1 is 0. Add this, we get 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Add this, we get negative 8. This does not work. So that means I have to try something else. Let's try, I'm going to put negative 1 in here. And I'm going to erase basically what I just did. All right, so I'm going to erase this and start over again. Okay, so I bring down this one, and negative 1 times 1 is negative 1. Add these, we get negative 2. Negative 1 times negative 2 is 2. 1 plus 2 is 3. Negative 1 times 3 is negative 3. Add these, we get negative 6. Negative 1 times negative 6 is 6, and it works. So I get a remainder of 0. Okay? Now, I know I have to use synthetic division. I have to get synthetic division to work twice because I want to get it down to quadratic because my original degree is a degree of 4. Now, I'm just going to kind of skip. I'm going to go right to, I already did 1 and negative 1. I'm going to put 2 in next. Let's see if that works. Now, when I put 2 in, I'm building off of what I just did previous. This right here is a degree of 3, so I want to get it down to a degree of 2. So I'm going to do synthetic division over again. I bring down the 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 3 plus 0 is 3. 2 times 3 is 6, and it works. Negative 6 plus 6 is 0. Okay? So what I've proven is that negative 1 and 2 are zeros. And if negative 1 and 2 are zeros, I've proven that x plus 1 is a factor, x minus 2 is a factor, and this is what we want. This is our quadratic. So this is x squared plus 3. Now the x squared plus 3, I can solve for that. I'm not going to use quadratic formula because there's no x. If I solve for this, well, x squared plus 3, I set it equal to 0. So x squared would have to equal negative 3. I take the square root of each side. So I'm going to have x equals plus or minus the square root of negative 3. Well, that's imaginary. I take out the negative, and it becomes plus or minus I root 3. So my 4 zeros are negative 1, 2, and then plus or minus I root 3. So really, all in all, I'm doing the same thing. I want to find all the zeros, whether they're real or complex. I want to use synthetic division until I get it down to a quadratic. And the rational zero test basically gives us a starting point of knowing what numbers or fractions to use for synthetic division. But a lot of it is just trial and error. We want to get our remainder to be 0 for all of these. I'm not going to do the next one. So the next one's what, number 4? Number 4, do this right now. Do this on your own so you can see your degree is 3. So find all 3 zeros. And we'll go over 4, 5, and 6 in class tomorrow.